Okay, let's start. Okay, guys. Now, so today we are going to spend at least 1 hour. We're going to talk about essay question because we want to focus for your July and August exam. So without further ado, let's start, guys. Okay, so kita pergi tengok one basic calculation on momentum first. Okay, so usually in your next term exam, guys, momentum will be your biggest problem. Okay, momentum. So in momentum, this question, right, I purposely combine momentum with something that is very simple, which is sticker tape. But if I combine these two together, these two, right, you have to use a bit otak to do. Okay, so without further ado, let's start. Okay, we see here we got A and B before and after a collision. All right, so they give me a bunch of sticker tape. Okay, guys, do you know why they need to tell you ticker tape timer punya frequency? Anybody know why they need to tell you the ticker tape punya frequency? Why? Anybody, any idea? Why you need to know the ticker tape's frequency? So because when we have the frequency of the ticker tape, we can actually use F equals to 1 over T to calculate, or we can switch this around. We can use T equals to 1 over F. And when we use 1 over 50, we can calculate the time taken is 0.02 seconds. Remember, guys, for ticker tape, they can actually kacau you by giving you something different frequency. You understand what I mean? So if they put this to be 40 hertz, if they put this to 60 hertz, the whole question punya jawapan will be very different already. Okay, no problem. Okay, but anyway, let's continue. So in momentum, what is a momentum? Momentum is like, for example, one day a car come and langgar you, then you die. But if a lorry langgar you, you will die even faster, correct? Why? Because lorry is heavier, right? So momentum is like a force whereby when it hits you, it will destroy you. Okay, not like force, but something like force. So momentum is affected by what? Two things. One is known as mass, second is known as velocity. So it's affected by mass and velocity. So how do we calculate this? We actually multiply them. So the momentum, meaning it is actually known as the product of mass and velocity. So this is actually the product of mass and velocity. We take mass and velocity times together. So when we do momentum, okay, a lot of teachers will tell you, momentum got what? Elastic lah, inelastic lah, explosion lah, a bunch of random stuff, guys. Those things doesn't matter. So in momentum, okay, what is the most important physics principle? So this is actually related to, guys, if you attend my class, we did this recently, fairly recently. So the physics principle here will be known as the principle of conservation of momentum. Okay, now before we even continue, okay, you have two choices here. Choice number one, you memorize formula. Okay, now, so let's say, for example, what formula? Teacher, what formula I have to memorize? So it's either you memorize this formula, which is what? The collision, elastic, inelastic explosion, boom, you have to memorize the whole entire formula. Or you understand the principle of conservation of momentum, which tells you that whatever happens before and after will be the same. Why? Because it's clearly written here. It says remains constant. So remains constant means whatever before and after will be the same lah. All right, Ken? It will be the same. Okay, so if you got no problem, so it's the principle of conservation of momentum. Now we have to talk about the process. Is this elastic, inelastic, or explosion? Now, how do we differentiate elastic and inelastic? Usually, guys, I say usually, not always. Usually, we can differentiate them by looking at elastic. Usually is after they langgar, they will separate. After they langgar, they will separate. But inelastic is usually after they langgar, they will stick together. So now, guys, if you look at this one, did the A and B stick together? Obviously, yes, right? Correct. So therefore, you will realize that inelastic, because they stick together. So my answer for this one will be it is considered as an inelastic collision. Okay, no problem, guys. Okay, so next one, we're gonna calculate the mass of trolley A if trolley B has mass of 2 kg. Okay, so now how do we do this without using the formula? Okay, korang tengok dulu ah. Now we have principle of conservation of momentum, which tells you that the momentum before and the momentum after is the same. How do we calculate momentum, guys? Momentum is just basically mass and velocity. You multiply mass with velocity. That's it. Okay. So now when we tengok ke atas, so if you want to calculate momentum, obviously you have to know on the left hand side, this is before. On the right hand side, this is after. They tell me that B has a mass of 2 kg, meaning to say, guys, this B is actually 2 kg and this is actually 2 kg. Now I want to find what is the mass of object A. Okay, mass of object A. Okay, I know the velocity of B is 0, meaning to say B actually started from rest. B actually started from rest. What about trolley A punya velocity? So how much is UA? Okay, korang tengok here first, you see here first. So it says here that the section A shows the motion before the collision. So meaning to say the section A here is before the collision, which means that if I want to calculate the velocity of A, so you guys know, right? Like velocity, we usually will use this thing called displacement over time taken, right? So it's clearly written here, 10 cm. Okay, do I need to change to SI unit? Not necessarily, guys. When there's sticker tape, there is no such thing as must change to SI unit. Okay, Erwin. Okay, Erwin. Okay, Erwin, today you help me press calculator, can I? Because I don't have calculator. Okay. So yeah, because Erwin, now you're famous, you know, because this video will be posted to the TTC YouTube. Okay, so which means that when people watch my video, they'll hear your name. Okay, now, so you take calculator lah. Okay, now, so when we want to calculate velocity, okay, I know that this is 10 here. So what about the time taken? Okay, how do we calculate the time taken? So it's a 1, 2, 3, 4, 5 here, which is there is a gap of 1, 2, 3, 4, 5. So meaning to say that here we will take 5 times 0.02. Remember, guys, when we calculate velocity, we take what? We take the gaps. Okay, what is the name given to the gaps? So the gaps are called ticks. So these are called TICKS, ticks, 1 tick, 2 tick, 3 tick, 4 tick, 5 ticks. So ultimately, this will be 100 cm per second. Okay, did I calculate correctly? So I think this is actually 100 cm per second. Okay, let me use green color. So this is actually 100 cm per second. This is 0 meter per second. Okay, Ken? Now, so what about B? B is after the collision. So they are stuck together already. So they stuck together meaning to say that they move at the same speed. All right. So now we need to calculate this part punya velocity. Okay. So what we're going to do here is V equals to displacement over time taken. So how much is my displacement? Okay. We want to do a calculation here. 1, 2, 3, 4, 5, 6. So there are a total of 6 gaps in between. So we got 6 multiplied by 0.02. This is 3 cm. So help me count this one. How many cm per second? Okay, so I know that this is actually the after lah, because they clearly tell me that this is the after, right? Okay, so I move up here. 25. Don't know. 25 cm per second. Yeah, okay. So which means that after that, they both move with 25 cm per second. Okay. Now, I don't know what this Erwin doing. Slow. Now, so now we want to calculate the momentum. Okay, we want to do our calculation. Okay, guys, I give you a very good special weapon. Okay. Now you see how I do this, okay, guys, without using formula. Now we know that momentum before and momentum after is going to be balanced, in which my left hand side AB must be equal to the right hand side AB. All right. So my left hand side ada siapa? So mass of A. So I'm just gonna write M multiply by 100. Okay, why? Because formula very simple. I mean, like when you want to calculate momentum, it's very easy. All you have to do is just need to take mass times velocity plus, guys, what is the B punya mass times velocity? Mass times velocity, right? So 2 times 0, right? Correct. Then after that, A here will be M, which is my unknown, M times 25 plus 2 times 25. 2 times 25. Okay, why both times 25? Because they both move together. They share the same velocity. All right, Ken? So which means, guys, you see here, now when I form this equation, I actually already used the formula. So you see, I just take mass times velocity, mass times velocity, mass times velocity. So in my opinion, okay, like example, Lushini, like what's the point of memorizing the formula, right? Like, can you imagine you got 2 choices? One of the choice is you're gonna memorize this thing, but actually this thing is just mass times your laju, your halaju, mass times your velocity, then mass times the velocity, then mass times velocity. So it's just the same thing, mass velocity plus mass velocity, mass velocity. So guys, there's no point in memorizing the formula, okay, in my opinion. So for me, I will just use a very simple way of presenting it, which is mass times velocity, mass times velocity. So mass times velocity, mass times velocity equals to mass times velocity, mass times velocity. So you come back to the same thing. All right, Ken? So come on, guys. I want to test you all punya maths. Maths. Okay, so Emily Wong, Fang Yu, Vincent, come on. Win K. Can you help me to calculate this? Come on, guys. Yes. Okay, I'm going to do this at the same time. Okay, this is 100 M. Okay, 2 times 0, of course, is 0, so, right? So I don't have to write anything, right? So it's going to be 25 M. Yeah, Li Shen, very good. So this is 50 lah. Then after that, I shift over, I will get 75 M. Because if you shift over to the other side, it becomes negative, right? Correct. So negative equals to 50, right? So M will be 50 over 75. Okay, guys, in our SPM now, okay, guys, in SPM now, in Form 4, do we usually leave our answer in fraction or in decimal place? Fraction ataupun decimal place? It's always in decimal place. So guys, this is 0.67 kg. 0.67 kg. Okay. Now, there is also recently satu khabar, that they say you need to write 3 decimal place. So because of that, a lot of school teachers now very demanding. They are looking at 3 decimal place. So okay lah, kalau your teacher wants it, right, then we just satisfy them, we'll write 3 decimal place. So tada, this is my answer. Okay, so I'm just gonna write this here. So this is it. My working is here. Okay, 0.067 kg. Okay, Ken. Now, guys, if you don't have, okay, guys, if you don't have the formula, I mean the formula, you can use definition to help you. Guys, if you don't have the what do you call that? Notes, you can screenshot this, guys. Okay, because lepas here, I want to go into essay. Essay very important. Okay, now so 0.667 kg, calculate impulsive force. Now, guys, since impulsive force is related to 2.7, and I haven't teach in my class yet, I don't want to answer this question first, but maybe later on we can come back to this question. Okay, so for momentum, I prove it to you guys. We don't need to know what collision. We don't need to memorize formula, as long as we know the momentum before and the momentum after is the same. Okay, Ken, all right. Now, let's look at our essay question. Okay. Now, first statement, guys, I'm gonna ask everybody. Anybody here, your school teacher already start teaching you essay? Already start teaching essay. Oh, so Bukit Jalil start teaching essay already. Wow, that's very cool. Yeah, that's very cool. Okay. Now, because for what I know, like a lot of people still haven't, your school teachers still haven't started essay yet. Okay. I don't know if your teacher lazy go. Okay. Now, so we look here. Okay. Now we look at page 14. Okay, I want to spend a few minutes talking about essay. Now, guys, one essay question is about 20 marks. This is one essay question. And do you know how many essay questions do you have to do? The answer is 2 essay questions, which means this is 40 marks. All right. Now, if your teacher or your school teacher or your tuition teacher or whatever teacher didn't menegaskan, never tell you that essay is important, that means that teacher is not doing a good job, because essay is important. It's 40 marks. Now, is it calculation? No, it's not calculation, guys. So let's look at essay question. Now, usually in the essay question 20 marks is broken down into first part and second part. So usually the first part will be like that one. It will be very theory. Okay, so they ask you, oh, this is a velocity time graph. They ask you what's the meaning of velocity. So in my class, I teach my students this thing, how to remember definition, how to remember what's the meaning of velocity. Okay, this velocity tak susah, guys. You see, velocity is actually equivalent to displacement over time. So every single time when this thing is divided by time, we will say that it is known as the rate of change of something. So if it's divided by this, S stands for what, guys? Can anybody tell me what does S stands for? Displacement law, 对不对? So it's the rate of change of displacement. That's it. Okay, rate of change of displacement. Okay, next. Based on diagram 11.1, describe the velocity and acceleration of the car movement. Okay, so when I do this kind of question, right, I like to look at the diagram first. We try to break down the diagram first. Okay, so I want to kacau some people here lah. Okay, I want to kacau some people here lah. So I'll start with this. So at BC, so Ziying, at BC, is the car moving? At BC, is the car moving? You first. At BC, is the car moving? So the answer is obviously yes lah. Okay, why? Because this is constant velocity, right? So if I look at my velocity and my velocity is constant, so this is a constant velocity. All right, a constant velocity, meaning to say that it's moving lah. All right. So because they want us to describe the velocity and the acceleration nanti, correct? They want me to talk about the velocity and the acceleration later. So now I want to talk about this one first. Okay. So at BC, okay, I write at the middle part first, because later I'll talk about AB, I'll talk about CD, but I want to talk about BC first. What's this? Is this a car? So the car moving at a constant velocity. The car is moving at a constant velocity, which is 0 acceleration, meaning to say that the car is technically not accelerating. There is a 0 acceleration here. Now, what about AB, guys? Okay, if you look at this line AB, at AB, you will see that car moving with increasing velocity. It is moving with an increasing velocity. So, guys, what happens here? So if I want to talk about acceleration, so I say, therefore, it is acceleration. Okay, come on, guys. Jin Yang, Wen San, Wen K, come on, everybody. Now, those people who have followed me for a while, Okay, if I write like this one, this line, what is wrong with this line? This line, you know how to say, I didn't follow one rule. What's the rule here that I didn't follow? Yeah, usually that's great. Okay, see guys. Don't forget, no, they want you to describe the acceleration. So if I say, oh, acceleration, oh, did I describe the acceleration? No, right? Because I just say, oh, acceleration, oh, I want to describe the acceleration. The acceleration is acceleration. It actually means that I didn't describe anything. You faham, right? So therefore, in this case, the proper way to do this is we have to say that it is actually constant acceleration. Guys, not increasing acceleration. Why? Because if we look at this gradient, okay, guys, just want to test your maths. Is this gradient constant or increasing gradient? Is this constant gradient or is this increasing gradient? Gradient. Constant gradient or increasing gradient? Hong Liang. Fang Yu, no. Fang Yu. The answer is constant gradient. Okay. Now, so gradient in Mandarin we call 斜度, in English we call steepness. Imagine if one day one guy go climb this mountain. Okay, he decided to climb this mountain. So if he climbed this mountain, you look at this mountain, right? It's actually like a straight line, right? So meaning to say that when this guy climbed this mountain, is it getting more and more susah or not? Is it getting more and more difficult or not? Is it getting more and more steep or not? No, right? It's a straight line. So meaning to say that it didn't become more sengit, it didn't become more steep, it didn't become more so gradient change, correct? So therefore, constant gradient. So what is the gradient? The gradient is actually equivalent to y over x. And when you take y over x, this is actually ms negative 1 divided by s. So this is going to be ms negative 2, faham, right? So meaning to say, okay, then we continue lagi ya. So this is actually constant acceleration because your gradient is actually this. So this is a constant acceleration. Okay, anybody got any question to ask me? You can put accelerating, but you must say constant acceleration or constant accelerating. Okay, can you replace with uniform? Of course can lah. Okay, uniform and constant apa tak sama, same lah. Can. Okay, can. All right. What is y over x? When you calculate gradient, Clement, how do you calculate gradient? So you will take the y2 minus y1 over x2 minus x1. 就是 ultimately you take y over x, correct? Yeah. So in short, I want to use that to help me see the unit. Or it's ms negative 2 like that. All right, Ken. Clement, good question. Okay. Now at CD. So now at CD, the car moving with decreasing velocity, right, guys? It's moving in decreasing velocity. Decreasing meaning to say that it's like slowing down macam tu lah. Okay. So what is my acceleration? So how to describe my acceleration? So what am I going to say here? Yeah, constant deceleration. Okay, you see, constant deceleration. Okay, remember there's always you need to always have a word constant lah, increasing lah, decreasing lah, everything. You need to use description. Remember, guys, describe velocity, describe acceleration. you will need two words. Okay, can? Okay, so now this is the first part of the theory essay. So this might be somewhere 5 marks, guys. Don't mind. This one maybe about 1 mark. Okay. Now the bottom part here, guys, this is going to be 10 marks. An essay question. Okay, can. Now, so a lot of students, right, when they see essay question, they get very scared. Why? Because let me ask you one question, guys. Have you ever studied a wheelchair before? Have you studied a wheelchair before? Never, right? Correct. Textbook got or not? Don't have, right? So today, right, even if you take textbook, even if you read a lot all the books, can you answer this question? Cannot, right? Why cannot? Because you can't find this kind of question. So ultimately, how are we going to answer this kind of question? Okay, the secret of how to answer this kind of question is you need to read, process, and decide. Okay, guys, I give you all 1 minute. Okay, choose which is the better wheelchair right now. Okay, you got 1 minute. I drink my water first. 1 minute. Come, guys. Okay, come on, guys. A, B, C, D. Oh, I think I know what's wrong already. I think some of you reply me to the wrong chat. Yeah, because got two Jung Hao here. I don't know if. Oh, the link message the other side. Okay, come on. Guys, message the Jung Hao, not the Jung Chiu. Okay. Come on. So PQRS, which one is your answer, Jaron? Jaron. Q. Oh, we got P, we got Q, we got like what else we have? Edition don't say don't know, come on, try. Okay, now guys, now when I was a student, right, when I did this question, I had one problem. I don't know what is an angle of camber. I'm like, what is an angle of camber? All right, guys, remember, when in SPM or when your exams, when they want to test you something you don't know, sometimes you can look for clues in the question. Okay, so where am I going to look for the clue to? Kat sini it says here, angle of camber. Oh, angle of camber. Okay, maybe. So guys, if today I know this angle of camber, I still have to check one thing. It's used in sports event by a disabled athlete. Okay, guys. So now, what is the purpose of this chair? Fast important or stable more important? Obviously, we're looking for fast, right? Correct? Because this is the disabled athlete in sports event. So obviously, this has to be like, you have to like go very fast. You have to go very fast on. Okay, can? Paham? So oleh itu di sini, okay, we have to see a problem already. Okay, angle of camber. Do you want bigger angle or smaller angle of camber? Come on, guys. Do you guys want to vote? Bigger angle of camber or smaller angle of camber? Okay. So I'm looking at something like probably can give it a bit more like stability macam tu, right? Correct. So okay, maybe I don't know how to see camber. Okay, but Saravanan, good try. Okay. Now we look at the height of seat first. Okay, guys. So what about this height of seat? Do we want it to be very high or very low? So we want to be very low, definitely. Because why? Lower than this, the chair won't flip, right? Correct. Okay, so even eventually I'm looking at lower height of seat. So which means the width of tire is already decided. I don't need to think much because the height, the height is a sure thing, low height confirm, which means I terpaksa choose the narrow tire. I terpaksa to choose the narrow tire. Okay, so meaning you say P and Q is like confirm wrong already. Now, guys, what about the diameter of tire? So does diameter of tire matter? Okay, guys, think about all those wheelchairs, guys. Those wheelchair, right? The tire very big or very small? It's usually very big one, right? Or if you imagine those mud rempit, right, guys? What's mud rempit, right? When they start to modify their car, do you get what I mean? Modify their car. Wow, they want to like put exhaust lah, put the wing lah, everything. They will always change the tire very big one, correct? Do you know why? The answer is we want a bigger diameter of wire, of tire wire block. Okay, because imagine if your tire very small. Okay, let's say this is the tire. If the tire is very small, and if this thing is going to pushing one circle, you will realize that it's going to move a little short distance. It's like probably it's going to move like that only. So it's going to roll a bit, like roll a little bit. But if today the tire is as big as this, so when this thing were to, if this thing were to pushing one circle, it's gonna go all the way maybe here, correct? Because why? The circumference is larger. So after like 20 rounds later, for it to go all the way here, maybe this one only need to turn 5 times. But this one maybe need to turn 12 times. So meaning to say this one will be faster because 5 rounds, then he's on by already. You understand? So ultimately, we want larger diameter of wire. That's why, guys, do you all like near your house, do you all see the people, they cycle? They like to cycle in the Kesas highway and all the highway, they'll cycle, and then after that, wear the helmet, tight shirt. You look at their tires are very narrow. You understand what I mean? Their tires are very narrow. Why they want it to be very nippies? Why? Yeah, it's definitely to do with friction. The smaller the surface area, the lesser the frictional force. Okay, so a wooden bigger tire will require more energy to be moved. Yes, yeah, Saranan, yes, you are right, but technically it will become faster. Okay, it's something like a balance between okay guys, I mean my background is engineering, so I do mechanical engineering. So if you have a bigger tire, you technically have a higher top speed, but you will lose a bit of torque. You know, torque, yeah, torque. So, but in this case, we care about speed. So therefore, we will go for a larger diameter. Okay, but anyway, narrow tire is reducing the friction so that it can naturally roll further. Because if you have more friction, then it will come to a stop faster, right? Okay, so okay, now want a larger camber. Okay, guys. So just now we come back to this point. This essay question is 10 marks. So Hong Liang, Lushini, Erwin. Now, if guys, if this question is 10 marks, all right, and I apapun tak tahu, I don't know how to describe anything. I don't know how to explain anything. But I just choose R. Out of these 10 marks, how many marks will I get? Guys, I repeat, out of these 10 marks, how many marks will I get? By choosing correctly. By choosing correctly, how many marks will I get? Okay, guys, you will be surprised. The answer is, as long as you choose correctly, you get 6 marks out of 10. So meaning to say, if you choose wrongly, then you're dead. Yeah, really. Okay. So the secret here is you need to train your brain how to choose correctly. Okay. Now, so which we have to like, like you need to spend more time on choosing. Okay, don't chin cai do this thing. Okay, I'll show you where the 6 marks are. Okay, so we go to the next part. Now, so Bukit Jalil people, you all learn essay question, right? Does your teacher tell you that you have to draw in a table form? Do you know that you have to draw in a table form? Okay, how this table is like is okay. First of all, we have to write the title first. Ini panggil aspects. This side will be your explanation. Okay, so we got aspects and explanation. So we got the first 4 columns, 4 rows are actually the first 4 columns. Okay, but guys, remember when you answer this, don't write too short form. Like for example, they see here big, right? They straight away write here or big like that. Can or not, guys? What do you think? Can or not? You say lah, can or not? Of course cannot lah, right? Big what? So maybe your teacher will say, you mean big angle of camber, or you mean big what? So you just say like you copy the title. So we can say something like the diameter of tire must be big. Okay, so you say the diameter of the tire must be big. So Jayron, I'm so sorry that I teach essay now, then your exam come out essay. 我也不想。Okay, all right. Now, so but anyways, let's continue. Okay. Now, so this diameter of tire must be big. Okay, I don't want to write the explanation first. Okay, I'm gonna just continue write all my points first. Okay. So second one, the width of tire must be narrow. So say so that the width of tire must be narrow. Okay. The third one, the height of seat must be low. So here, okay, the height of seat must be low. Then the fourth one will be the angle of camber must be big. So you just say, so therefore the angle of camber must be big. Okay, diameter of tire must be big, angle of camber must be big. Macam tu lah. All right, Ken. Okay, so no problem. Okay, so how many marks are we gonna get here? We got 1 mark, 2 marks, 3 marks, and 4 marks. So we got total 4 marks already. Macam tu. Very simple step. Okay, then, but Jung Hao says 6 marks, right? I only found 4. Where is the other 2 marks? Do you guys know where is the other 2 marks? Yeah, we need to write like the choice, right? Because this is a choosing question, right? So what choice is this? We're gonna choose R. But guys, don't just say R. We say that our choice is wheelchair R. You see, guys, I'm still using the title. So it's actually wheelchair R. So wheelchair R. Okay. Then another 1 more mark already. So I've got 5 marks. And do you know the 6th mark is actually very easy? Because all you have to do is you just have to say everything, the whole grandfather story again. What do I mean by grandfather story? You just have to say like, why you choose R. So guys, why do you choose R? So you write down the whole title again. It must be a big diameter. Why? Because it has a big diameter of tire. The width is narrow. The height is low, and the angle of camber is big. Okay, can the width is narrow and the angle is big. Okay, can all right. So like that means you say you rewrite, you actually summarize everything here. You summarize everything here, so you get another 1 more mark. So that's why you see, guys, as long as you choose correctly, you don't know how to explain, still not so bad. If you know how to explain, then that's like bonus point. You get like bonus style points for that. Okay. Now, so why the diameter of tire must be big? So that it can travel with higher velocity. Okay, can move with a higher velocity. Then after that, why the width must be narrow? To reduce friction between road and wheelchair. Okay, so between ground and wheelchair. And then after that, the third point is upper lagi, guys. Upper lagi. The height of seat must be low. Guys, why must the height be low? Can anybody teach me why the height must be low? Okay, guys, don't just say stable. What causes it to become stable? Because it has a lower center of gravity lah. Yeah, you guys, you have to like use specific points to talk about it. So DCD, what do we have? We have lower center of gravity. Okay, Ken. Then the fourth one is we're going to talk about the angle of camber. So what about the angle of camber? Why bigger angle of camber? Because okay, this one you can say increased stability, but this is also increased stability by increasing the wider base area. So they both punya aim is the same, to increase stability. Tetapi the way of how you achieve is different. And the way how you achieve it is different. One is lower center of gravity, one is wider base area. Ching, 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 done. Can. So this is our essay question. So if you get the theory correct, then you will have 1, 2, 3, 4. So that then you get the other 4 out of 10. So yeah, 10 out of 10. Okay, no, cannot, guys. Okay, guys, I ask you a question now. Do you think is it easier to get marks in calculation or easier to get marks in essay? What do you think? Okay, if you ask me, I will say essay. Because it's calculation. You have to do, okay, let's say 10 marks. How many calculation do you need to do to get 10 marks? So calculation, maybe you have to do like 4 calculations because some 2 marks, some 3 marks. You have to get 4 formulas. You have to memorize 4 formulas to do 4 calculations to get 10 marks. Essay, as long as you try to explain, then you will be able to get these marks. Okay. But usually, guys, if you are bad in English, anybody here English very chacha? If you are bad in English, then you have a problem. Okay, can. But I don't think you guys punya language very chacha lah. Okay, can. Okay, now let's look at the next part of the question. Okay, now guys, I'm gonna do one more essay question, because we only have one more hour remaining. But I'm gonna do one essay question. I'm gonna do 2 graph and I'm gonna do 1 free form. Okay, I don't know if we got the time to habiskan or not, but we will have to lah. Okay, kan? Now, jom kita tengok page 22. Okay, after this essay question, I'll give you all a water break. Okay, like a short water break. Okay, you let me do this essay question first. I'll give you a water break. Okay, now guys, look at this page 22. Okay, guys, is this an essay question? Is this an essay question? Yes. Yes, of course. Why? Because you look at the bottom here, sudah ada the table, right? Correct. Now, I'm gonna let you all do something very simple. Can you tell me this essay question and tadi punya essay question got what difference? Come on, Owen, you think about it. This essay question, right? Why is it different from just now punya essay question? Okay. No. Because the answer here is here, you are not doing a choice. Your aim here is not going to be like pick PQRS, choose A, B, C, D. For this one, it's harder. Why? Because you cannot tembak. Okay, example, guys. Can you tembak just now that one? Can you tembak this PQRS? Of course can. You can tembak this. But can you tembak this? Cannot, right? Like how you gonna tembak this? Because everything is like one by itself. So yeah, so we need to think a little bit here. Okay, so we want to do here whereby it can travel a maximum horizontal distance. Our aim here is to travel maximum horizontal distance. So using the knowledge of forces, motion properties, then I explain the modification based on the following aspects. Okay. So I'm trying to do a water rocket. And by the way, this water rocket is one of the, okay, why I write one here? Because I think this one has a very high chance to come out in your exam question. Okay. What exam? The July, August exam. Okay, I repeat the July, August essay question. You want stand by, I tell you. Okay, now. So using the knowledge of forces, then I explain the modification based on the following aspects. Okay, guys, look here. So what's maximum horizontal distance? Means that when I launch this water rocket, I'm looking at launching it at about 45 degrees. So that this one can fly the furthest. Okay. You guys got play Angry Bird before or not? Or is that an old people game? Okay, because if you got play Angry Bird before, you realize, right, that if you tarik too high, if you go too high up, it's just gonna drop like that. Okay. If you go a bit flat, if you go very pian, okay, what you will have is you will have something like this. It will reach the ground very fast if you go very flat. So now the most optimum angle of launching is always 45 degrees. Okay, guys, remember this important 45 degrees okay. Now then, what about other things? Okay, so let's just start. It's still the same thing. It's still aspects dengan explanation. It is still the same thing. It is aspects and explanation. Now, how are we going to talk about the first one, material use? Okay, guys, anybody want to like suggest? So what material should I use for my water rocket? Okay, can you see guys? Okay, you guys come up. I want more answers. Very creative, you guys can answer. Ziling, can you help me? Okay, no, not necessarily based on the diagram. Okay, meaning to say you can say anything here. You can say literally anything. Material. Okay. The most common answer that I get people say will be they're saying like use plastic bottle, use water bottle, use plastic stuff. Okay. Now guys, when I say plastic bottle, how many types of plastic bottle are there in this world? Okay, if I say plastic material, how many types of plastic are there in this world? Okay, can you imagine? If you go to school and you sit on the chair, school chair is made out of what? Plastic, right? That plastic can fly or not? Okay, then we talk about plastic bottle. Those like Tupperware bottle, those Tupperware, like the very typical orange color, red color, blue color. Every student has it. Every parent's favorite bottle is you know what I'm saying, right? The Tupperware. So those cannot fly on. So why do we try not to write plastic bottle? I will say by using a low density material. Okay. So low density material, okay, in physics, everybody here knows that density is actually this thing, mass over volume, right? Correct. Because mass over volume, right? Okay. So low density material means that I'm looking at a lower mass so that it is lighter, so that it can have higher acceleration. So it can like fly to the sky, it can accelerate towards the sky. Okay, can accelerate faster. Okay, no problem. Number 2. What about the shape of rocket, guys? Anybody got any idea? What about the shape of the rocket? Oh, not bad, guys. Okay, come on, guys. Don't say, okay, some people very cute and they'll say rocket shape. They'll say pointy shape. They'll say sharp shape. Come on, guys, but we're not looking for those. We want something that can allow the rocket to fly, to like pass through the air easily. So what's the name of that? No, not sharp, not sharp. No. The answer is aerodynamic shape. Hey, don't tell me you'll never hear this word before. Aerodynamic means like, cars, like greater. Cars can be aerodynamic also. How does it mean? It means like those sports car. They are like, the shape, they will curve up, and like there's this streamline shape that, yeah, so that's what we call aerodynamic shape. Okay. Now, so aerodynamic shape, apa advantage? It can reduce. Okay, guys, I can accept reduce, lower, lesser, and so on. So it will reduce lower air resistance. Okay, when you reduce air resistance, what happens? You can say so that it can travel further, and so on. Okay, because or higher velocity also can. Okay, you can say higher velocity also can. Okay, because you see, if you roll a ball onto the floor, the higher the resistance means more friction on the floor, the faster the thing will stop, right? All right. So therefore, if the floor is smooth, it will go further, right? So that's why my aerodynamic shape is to reduce the air resistance. Okay, can remember this one, high chance in your SPM, guys. Not SPM, sorry, your July August exam. Okay, now, so third one, okay, angle of launching. Wah, tiba-tiba kita cakap 45 degree. Okay, like I say, right, if you play Angry Bird before, you will realize that this thingy will go 45 degree. It will go furthest because 45 degree, it will be ngam highest, not the highest. It will travel far enough. Okay, so we'll say angle of launching is 45 degree. Okay, can. So now, okay, why? So we use back the term lah, because 45 degree can travel maximum horizontal distance. Okay, it can travel maximum horizontal distance. Okay, then number 4. What about the volume of water in the rocket? Okay, guys, I've got one question here. Kenapa water rocket inside? They want to add water. Why? Okay, no. Okay, see guys. I use a very cartoon reference. Okay, guys. You all watch cartoon before, right? Now, if let's say this cartoon guy, if he fart, right? Okay, if he fart, what will happen to this guy? It's a very, very typical cartoon, guys. If this guy fart, what will happen to him? Or you don't watch cartoon at all? So this guy will like, this as he farts, right? He will move forward, right? Correct. Right, guys. Why? Because there's a proper theory behind it. Because why? This back momentum, the backward momentum, will be equals to this, so-called forward momentum, right? Correct. Larva, not okay. Yeah, I don't watch Lava. Lava is like too young for me. And the bug very ugly. Now, okay, now so forward momentum, backward momentum. Okay. So this is a very simple theory. Something moves back, it will push you forward. So if you fight backwards, then there'll be a forward momentum that will push you forward. Okay, can. Now, guys, then we look at the next part. Example, what if today we got a bottle? Okay, guys, we got a bottle. Not a bottle, right? So we got a bottle like that. So inside this bottle, we add water. Okay, we add water inside this bottle. Okay. So when I launch this bottle, water will come down. So the water will give you a momentum going down. So it will push this thing, creating another momentum going up, right? Correct? So I add more water, guys. Okay, let's just test Erwin if he attend class or not. So Erwin, how do we calculate momentum? Oh no, man, so easy lah, son. Tak susah pun. Okay, guys. Anybody tell me, Ziding, how do you calculate momentum? Yeah. So that will be like mass times velocity, right? Correct. So why they purposely put water inside is because when the water come out, water is heavy, right? So if your water is heavy, there will be more mass flying backwards, flying down. So this more mass will create the momentum to have more momentum to push this forward. You faham? Mean to say that you have more mass to create more forward momentum that will push this thing upwards. Boleh? So therefore, but can we fill all with water? Tak boleh. You have to fill this with 1/3 of rocket filled with water. Okay. You cannot fill 100%. Because if you fill 100%, it will be too heavy. So to produce larger backward momentum, to create forward momentum, to push rocket. Okay, faham? So what you want to do here, you want to produce a larger backward momentum to create forward momentum to push the rocket. Okay, Ken? And lastly, guys, additional structure. So what kind of additional structure do you need? Okay, come on, guys. If you answer this correctly, I'll give you a 5-minute break. Come on. So in a rocket, what do we need to add here? Add sayap. Cannot. Sayap cannot. Anybody? Okay, guys. For rocket to fly, right? Okay. Your aim is now you want it to go far. What do you need to add? A wing, a launch tube. A launch tube actually acceptable. Wings now. Okay, come on, guys. There's a proper word for this. We call it fins. This one. Anybody want to guess? What's the purpose of the fins? What's the purpose of the fins? Okay, see. Now imagine if I launch a rocket. Okay, guys. Imagine this is a rocket. I know this is a scissors, but okay. So if I launch a rocket, and as the rocket goes up, it starts spinning like that. So it starts spinning. Is it good or bad? It's bad, right? Because if it goes up and then it starts spinning, it will you will have a lot of air resistance. You know what's air resistance? It's like it will slow down the rocket rotating. So therefore, I don't want the rocket. I want the rocket to move, glide through, no one rotate. So the answer here is I can say I can add fins. So when I add fins, I will ensure that it will prevent, so that I can prevent, guys, you can say rolling, you can say rotation, prevent rolling / rotation of rocket. So therefore, it can travel further. Or you can say so as lesser resistance. Okay, can I, guys? Okay, not bad, not bad. Okay, now, okay, you see, when you say give more stability, you need to explain how is more stability. Whether is it like wider base, lower center of gravity, this kind of stuff. You have to say like this. Okay, can, all right. Now, guys, I give you a 4-minute break. Okay, we'll come back at 5:20 p.m. Okay, I know you guys are almost half day already. Okay, now after we come back, okay, 5:21. After we come back, I want to do graph. I want to do graph. Graph is important. And then after I'll do one free fall. Okay, free fall motion. Okay, now I'll see you in 4 minutes, guys. Okay, Ken. So if you guys got no problem, then let's continue. Okay, interesting. Okay. Okay, now, so what's gonna happen here is our next part. Okay. Now, we are gonna look at a graph question. Now, I've selected something very difficult. When I mean difficult, it means very difficult. Okay, okay, question 7 first. Okay, question 7 first. Okay, so let's see here, guys. This is a typical velocity time graph. Okay, the problem with velocity time graph is how do we know what okay, if I want to find acceleration, how do I know what should I find? What should I look for? Okay, remember, guys, my strategy is very simple. For every graph, gradient might mean something. It will always mean something. So guys, you all know, right? Gradient is always the y2 minus y1 over x2 minus x1, right? Correct? But we don't do that, right? Because we know that it's actually y over x. So this is meter per second, this is second. So this is ms negative 1 divided by s. So this is ms negative 2. Right. Okay, ms negative 2. So if I know that this is ms negative 2 because ms negative 1 s, so I want to find acceleration. The acceleration is actually the gradient. And the acceleration is actually the gradient. Now, then, what about another one more information? Now, guys, sometimes we can calculate what we know as area under graph, correct? Now, how can we calculate area under graph? I mean, when we calculate area under graph, what will we get? So if I calculate area under graph, I will take velocity multiplied by time, which is I'll take v multiplied by t. Okay, because when you calculate area means you multiply things, right? Correct. So if I look at velocity equals to s over t, and I take v multiplied by t equals to s, so this is actually v multiplied, because if I shift this up, I will v multiply t, right? So I'll get s, right? Correct. S will be this thing called displacement. Correct, no? Betul, no? Also called distance. Okay, also called distance. Okay, now anybody got any question? All right. Okay. So guys, first one, how to calculate acceleration. So now we're going to calculate the gradient. So the gradient of the first 3 seconds. Okay, guys, how do you calculate the gradient of the first 3 seconds? Come on, guys. So okay, now if you guys for me, I won't use the y2 minus y1. Okay, Jung how use this like a weird method. Okay, now I know that there's a triangle here, right? Correct. Now, so this is 15. Wait, guys, just give me 10 seconds. Okay. Wait, guys, just give me 10 seconds. Okay, now, so we see this is 15 and 3, right? Correct. So if you don't want to do coordinates, what you can do here is you can take 15 divided by 3 to get 5. So acceleration, you can actually take your y-axis divided by x-axis. So my strategy of calculating gradient is I will use something like called a triangle method, whereby I'll take 15 divided by 3 to get acceleration 5. Then what about the unit, guys? I'll just divide this lot. So it'll become ms negative 2. Okay, can? All right. So I use triangle method. Okay, then next, what about the deceleration, guys? Okay, for the after 3 seconds. So after 3 seconds, it will be this one. Correct, 3 to 6, betul kan? So, okay, can you count this, guys, for me, please, please? So 1C. Okay, now, so we see, now if I want to calculate the deceleration of the particle after 3 seconds, so deceleration means I have to calculate the this gradient, this part, right? Correct. So for me, I always like to draw triangle, which means that I'll draw like that. Okay, like that. Like that. So we'll always take 15 divided by 3. So negative lah, correct? It'll be negative 15 over 3. You guys, you can use your own method to calculate whatever you want. I mean gradient. So for me, I'll do it this way. So my acceleration at this part is negative 5, which is negative 5 ms negative 2. And then, but because this soalan wants me to find the deceleration. Okay, no guys, deceleration. So deceleration means I have to tukarkan this thing to something else, right? So therefore, the deceleration is actually 5 s negative 2. Can I understand? Okay, can I? Okay, Gerard, you still with me? Okay, guys, can. So now, why I want to calculate gradient? Because you see, the gradient is actually your acceleration. Your gradient is actually your acceleration. Now, what is the total distance traveled? Okay, so we need to find area under graph. Okay, can. Now, anybody here, you all got like a strategy to do this or not? No. Okay, guys, I give you all a mission. Okay, I give you a mission because this sounds a bit like boring, right? Okay. Now, yeah. Okay, we need to know that if I want to find the distance or displacement, we need to use the area under graph. So at this point, this is a pink area. This is a pink area. This part is a positive velocity. Why is this a positive velocity? It means that the object is moving forward because why the velocity is positive, so it's moving forward. Faham, right? Okay. Now, then look at this one. So negative, correct? So which means that we got pink is moving the forward direction, blue is moving the backward direction. So guys, can you help me to count the area under graph? Please and thank you. So Jing Yang, Li Xuan, Hong Liang, Clement, Wing K, Wing Tuan. Can we to calculate the pink and the blue part? 40咩？哪里是 ？No, no, no, guys, no, 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 no. Okay, the answer is, if you see here, this is 6, right? Hey, you don't know how to calculate your triangle. Half times height. Height is 15, right? The base is 6, right? So therefore, this is actually 45 meters. Yeah, you didn't multiply by half. So the pink is actually 45. Hello. Okay, Ken. Then after that, then we look at the blue one. So the blue one will be also triangle, right? So which means this one is going to be 2, this is going to be 10. So my triangle is going to be half 2 times 10 up. So this is going to be 10 meters. Because it's a cut, right? So I'm going to have 10 meters. 10 meters, meaning to say this is going to be 10 meters. Okay. Now, how do we differentiate this? Because you see, there's something called total distance traveled. There's something called displacement of the particle. So, upper base of these two things, guys. What's the difference between these two things? So distance means that we want to find how much the person walked, right? Okay. So let's say the guy walked here 45, then pusing balik 10. So my total distance traveled will be 55 meters. Why? Because I will take 45 plus 10 equals to 55 meters lah. Right, correct. But then after that, what about the displacement? So displacement is, this is the starting point, right? This is the ending point, right? So your distance between your starting point and your ending point. So guys, how to find this question mark? That's your displacement. So answer will be 45 minus 10 equals to 35 meters. Okay, can can okay, okay, now, so now how to draw the acceleration time graph? Okay, so you see guys, in motion graph, right, you need to be able to master two things. Okay, first is you need to know how to from here calculate the information out. Number two is you need to know how to draw the thing out. Okay, draw the thing out. So calculate that you need to know how to draw. So when you say draw, what do you mean by draw here? Sketch the corresponding acceleration time graph. So this is our velocity time graph. How does the acceleration time graph look like? So the acceleration time graph will be like this. Okay, so this is acceleration ms negative 2t slash s. Okay. Now, do we know what's the acceleration here at the starting point here? We found that this acceleration is actually 5, right? Correct? The acceleration here is actually 5, right? Then what about the acceleration here, guys? This part, the yellow color line here. Oh, wait, I use yellow color line here. This part is -5, right? Okay. What about this part? The pink color part. Guys, this one very challenging. The pink color part punya gradient is how much? The pink color part. Obviously, it's going to be a negative number, right? Yeah, obviously, guys. Obviously, it's going to be a negative number. It's still -5. Okay, how do you know? Okay, selain daripada you can count it, you can also check, guys. You take a ruler and you ask yourself, is this line a straight line? You take a ruler and you put down and see, is it a straight line? Is this a straight line? Yes, right, correct. So therefore, if a straight line, that means the gradient and this gradient is the same. Okay, can. So now we got 3, 6, 8. So the first 3 seconds, I realize that the acceleration is 5. So I'll draw like that. This is 5. The acceleration is 5. And then after that, from 3 to 6 to 8, the deceleration is the same, -5. Okay, Ken? All right. So therefore, there's a 5 and there is a -5 here. Okay, no, Ken? You faham, right? Faham you? Okay. So 3 to 8 is the same answer because you see, from 3 to 8 is straight away the straight line. Yeah, boleh ya? Okay, so now, okay, this one, no problem. Then we look at another one more thing. Yeah, can I? Okay, so therefore this one, no problem. Okay, I show you one slightly more challenging question. Then we do one more free fall. Then we can end our day already. Okay, now, so far, do you think the question that we do today is like difficult? Is it difficult? Okay, not difficult. Because you also never transition. Okay, page 16 guys. Okay, now let's look at this question number 6. All right, guys, look at my dog. My dog is actually attending physics, so if you guys tired, you go to her. Okay, can now. Okay, so come on, guys. We got another 20 minutes more to go. Come on, guys. Everybody, hang in there. Hang in there. Okay. Now, okay. So the first question: what's the acceleration of m in the first 5 seconds? So again, if this is a velocity time graph, we are actually trying to find the first 5 seconds punya gradient. Okay, can you help me to calculate this gradient? Okay, guys. So this O to P gradient first 5 seconds, how much? How much is my gradient? Oh, guys, gradient. Boleh tolong gradient. Gradient. You sure? Okay. Jawabannya is, okay, you will see that this is actually 2.4. How do you know this is 2.4? Because I use 12 over 5. Okay, guys, you will slowly get used to my method whereby you just look at it, right? You like straight away, boom, get 2.4 already. Okay, Ken? So the acceleration will be 12 over 5 equals 2.4. Where's I used to? Done. Okay. Now, then sketch the acceleration time graph. Okay, so this is like, guys, this is very cruel. Okay, why? Because it's very cruel. You have to do the sketching. Okay. Now, of course, which is easier to sketch? If you look at this question, first of all, they tell you that OPQR for M, OPQR for M, then OQT is for N. Meaning to say this line is the M line. Okay. Then after that, this is the N line. Okay, Ken? So the OPQ is the M line, that's the N line. Okay. So now kita tengok next station Okay. The OPQR. Okay, we draw OQT first. It's easier to draw the pink color one. Okay, so what's the acceleration for this N? N punya acceleration is how much? So we have the whole thing like a triangle here, right? Correct. So therefore, this is 16, correct? The bottom part is how much? 20, right? Correct. So therefore, we'll just say it's 16 divided by 20. So the answer is 0.8 after acceleration. So it's a constant acceleration. So I can just draw straight away until 20 here. This is n. That's 0.8. So this is very easy, guys. This is like very, very easy. Okay, Ken? Okay, I can. Okay. Then what about the orange color one? Okay, orange color one a bit lecture. Why? Because you have to do OP first. So from 0 to 5, the acceleration is actually 2.4. Okay. I've calculated this already. The acceleration is 2.4. Okay, let's just catch somebody off guard. Okay, who should we target today? Okay, we target the Erwin. So Erwin, PQ acceleration is how much? The PQ acceleration is how much? I target you, aim you one. Who call you don't have book? Okay, guys, obviously, right, here is constant velocity, right? Constant velocity means acceleration, 0 betul kan? So if your acceleration is 0, means from here to here is 0. Okay. Ayo, just I give you the easiest question. You just type 1 0, so you win already. But okay, next. So therefore, the height of this thing is 12. The base of this thing is 5. So again, the gradient here is negative 2.4 because why this is deceleration. So there's like a here, down here. This is gonna be negative 2.4. Okay, can. So there you go. That's what your answer looks like. Okay, this kind of question a lot of marks. Okay. Now, but the bottom one, I don't want to talk about it first. Okay, guys. The M or M1, okay, you can do this yourself. If you understand it, it's actually very easy. Okay, Ken? Guys, are we ready for our last question for today? Okay. What are we supposed to do our last question? What's the what okay, let's see who dreaming. What was the thing that we're supposed to do? We forgot. Okay. So let's look at question number 4. Okay, page 12, free fall. Okay. Now, for free fall, this is going to be a bit more chacha. Okay, why I use the word chacha? Okay, because a lot of people actually don't understand free fall. They feel like free fall is just a simple thing. The calculation is other formula. Guys, I show you, it's actually very, very, very similar. Okay, first of all, what is the meaning of free fall first? Free fall means you are falling freely without air resistance. So the definition is, we will say that whereby it's an object falling due to the effect of gravity only. So it's falling due to the effect of gravity only without air resistance. Okay, so it's only falling due to the effect of gravity without air resistance. Okay, then after that, so when you fall due to gravity, what is your acceleration, guys? When you fall due to gravity, what is your acceleration? So when you fall freely, what is your acceleration? Siapa tahu? Yeah, okay, guys. You don't have to be too worried about like what positive or negative or whatever. Okay. If you fall due to gravity, how much this you don't know. Are you sure? Okay, the answer is 9.81 lah. Adoy. 不行 lah, you guys. Okay, after that, so that's acceleration. Okay. Calculate the velocity of the athlete just before he drops on the mattress. Okay, so if this guy is gonna fall from M all the way down, okay, guys, when we do free fall, is there other formulas that we need to know? Because we want to calculate. So is there any other formula that we need to know? Got 3 formulas. What are the formulas, Sarana? Very curious. Like what? Okay. Okay, for me, guys, if you are Sarana, I'm very curious, which school are you from? Now, for me, if you have been following me for some time, I call this the SUVAT. Okay. So what is SUVAT? SUVAT is the SUVAT, whereby it's the same thing. Okay, guys. All you 3, 4. Okay, now. So SUVAT is whereby you just use this the 4 formulas to help you solve your answer. Okay, the formulas are what? S equals to UT plus half AT square, S equals to U plus V over 2 times T, V equals to U plus AT, and V square equals to U square plus 2AS. Okay, can? Now, kita tengok. Calculate the velocity. Okay, so now this guy, as he falls, his initial velocity confirms 0, right? Final velocity is question mark, right? Because we want to know what is his final velocity, right? Acceleration confirm 9.81. Time taken, they tell me 2 seconds here. So 2 seconds. So therefore, there is no S here. Guys, if no S, okay, can anybody tell me which formula am I going to use? Is it like the first one, second one, third one, or the fourth one? Thank you, Emily Wong. Now, okay, so you see, see this formula have no V. The first one have no V. The second one have no A, no S, no T. Okay. And I heard, right, some teachers are very pattern one, you know. They even will call you to like change this to what? Half GT square, half GS like that. Guys, it doesn't matter what alphabet you use, one. As long as you understand it, doesn't matter what alphabet you use, right? So okay, we're gonna do V equals to U plus 80. So V equals to 0 plus 9.12. So my final velocity will be 19.62 meter per second. I think so. 19.62 meter per second. Yeah. Okay, now can so guys, you see, all in all, the formulas are the same one. We use back the same formula, use back the same information, use back the same everything. Okay, then we go to the next part. Calculate the height of the pole from the metal position. Okay, so now, guys, what formula again? Is there a formula? No formula, right? It's still the same SUVAT method, right? Correct now, guys? It's still the same SUVAT method, right? So, okay. So what's my SUVAT method here? So height I want to find is the displacement, guys. Remember, S stands for displacement. S stands for displacement. Initial velocity 0. Final I count already, 19.62. Acceleration is 9.81 times 2 seconds. Okay, guys, you see this scene, I got all the information. I got SUVAT. So which formula do you think I should use? As which formula do you think I should use? One, two, four. What do you mean 1, 2, 4? Means I use all 3 of them. Or either one. Okay. Now guys, you see, okay, actually you can use a lot of formulas. Actually, you can even use the 4th formula. Okay. But which is a smarter choice? The first one. Why? Okay, because you see, Hammond cannot. Hammond, you see, if you want to find S, you want to find S, then you use this one, right? Use the 3rd one, right? Inside got S, not no S, they cannot. Okay. Now, see, okay. Let me ask you one question. If I get this V wrong, if let's say one day I accidentally got this to be 200, I don't want to affect this answer. You get what I mean? So the secret is, although I have the final velocity, But I assume I don't have V because this V is I calculate, bukan given one. You get what I mean? So therefore, I will try to use without V, which is the S equals to UT plus half AT squared. So I don't rely on the formula. I rely on my own answer. I use something that's not related to my formula. So S equals to kosong times 2 plus half 9.81 2 square. Coincidentally, guys, 19.62 meter. Guys, this is coincidence only, bukan always one. Coincidence. 19.62. Okay. No problem, right? Okay. Now, if so far so good, then kita pergi next part. Okay. Now, here shows a feather and an iron ball dropped in a container containing air and in a vacuum container. Okay. So what we have here is, boom, this is in air, then this is in vacuum. Okay. Explain the observation in both situations, guys. So can you guys, like, come on guys, this is the last part already. Can you agak tell me, so what happens here? What happens here, guys? Da, da, da. So Rushini, I mean like in air, in or vacuum. Huh? The feather will fly upwards. The feather will fly upwards. Tomorrow. Okay, come on, guys. It won't fly upwards, okay? Now, what is in air? Air basically talks about air resistance. Air resistance 就是 something that will technically will slow you down, right? Air resistance, ma. Then what about in vacuum? In vacuum, then I have no air resistance. Okay, tiada air resistance. So one is with air resistance, one is with no air resistance. Okay. So what's the difference here? What's the difference here? Explain the observation in both situations. Okay, so we can say that in air, okay, because I got 4 lines in air, so I talk about the observation first. I talk about observation and I explain. In air, the iron ball will reach ground faster than feather. Okay, the iron ball will reach the ground faster than the feather. Why? Because in air, iron ball has smaller air resistance. It has smaller air resistance than feather. So therefore, it has a higher acceleration. So meaning say because the ball is like it's a round face, so as it drops, right, it's gonna pass through air faster, right? Why lesser air resistance? Kalau lesser air resistance means that it will have a higher acceleration. That's why it will chong faster downwards. Okay, Ken? Next, then we're gonna talk about in vacuum. Now, so in vacuum, iron ball and feather will reach ground at the same time. It will reach the ground at the same time. Okay, Ken? Okay, so why? Guys, how? Then we say because in vacuum, oh my God. So guys, because my hand very sweaty already. Now, because in vacuum, the there is no air resistance. So therefore, we can say the iron ball and feather will have what? Same acceleration. So the iron ball and the feather, they both have same acceleration. Okay, guys, I'm just sorry if my words are very ugly lah. Okay, it's, you faham then can liao lah. So therefore, they have same acceleration. Okay, Ken. All right. Okay, now, guys. Now if you guys allow me 3 minutes, every time seminar, I like to do a recap just to we revise a bit what have we done the whole day. Okay, because now we are at our belakang stage. Okay, but before I do my conclusion, does anybody got any question want to ask me? Does anybody have any thing that you want to ask? No? No? Really? Okay, really. Okay, now if you got nothing to ask me, then okay. Now let me just do my small mini conclusion. Okay. So guys, what did we do the first thing today? Who remember? What did we do first thing today? Yeah, okay, very good. Okay, so we did the momentum. But the momentum got special one, got ticker tape one. So that question is very fancy one because you need to know how to do both, baru you can do that. The most important insight here is there's something called the principle. So make sure you understand and memorize the principle. Okay, that's okay. Saranan. Number 2. So selain daripada this thing, the momentum and the ticker tape. Okay. The second part we went to essay question. But today, if you realize, we did 2 essay question. So what was the difference? So the first essay question we do is whereby you get to choose, meaning to say like there's like a PQRS, you just have to do a choice, so you can tembak and it's easy marks. But the second one, you are asked to modify. And modify tend to be a bit more complicated. Okay, why? Because you have to talk about the characteristics, you have to be able to explain. You cannot tembak this one. So this is going to be a bit more complicated. Okay. Remember, guys, lorry and trucks are also another favorite question. Favorite question. Okay, Ken? Now, number 4. Number 4. So what do we have here? Okay. So after we did the essay and the essay already, what did we do? So we took a break. Then we come back, we did the graph, correct? So we did the motion graph. We learned how to draw acceleration time graph. And we also learned how to calculate what is the difference between distance / displacement. You guys have to understand that because you need to be able to know like okay, distance we will add together how they move. Displacement we will like potong half. We will minus if he turn back lah. Okay, Ken? So therefore that is on the calculate the distance and the displacement. Okay. And number 5, guys, what did we do? Number 5. We did the whole thing on free fall. Okay, Ken? You need to remember when it comes to free fall, we are still using Sufat. So that when exam comes out, right, you won't gonna stun. Some people will gonna stun like exam, they don't know what kind of essay, what kind of formula are we gonna use in free fall, but it's actually Sufat. So some of the school teachers, they will write v square equals to u square plus 2gs, but it's actually the same as v square equals to u square plus 2as. So you don't have to stress yourself over. It's not new formula, it's a fixed formula, it's the same thing. Boleh tak? Okay, can. All right. So far so good, right? Okay, now. So guys, how was every day? Today, okay, productive. Okay, as you can see, we today just focus do question only. We didn't spend time teaching. We didn't spend time going through all the basic stuff. So if you are a bit lost, okay, come and find me. Okay, you definitely can ask your friends, or you can somehow find me, be able to contact me. All right. And tell me, oh teacher, I don't understand this thing. Okay, can. Now, if okay, if you need the recording, okay, you can get it from either TDC official channel, or you can go to my YouTube channel, which is Physics by Jung. Okay. Now, temporarily in my Physics by Jung, I only have BM and English syllabus, but most of it is in Mandarin form. Okay, it's in Mandarin form because I can't do so many versions, so I can only do BM and English, but in Mandarin form temporarily. Maybe in the future I'll do some English version, English stuff. I don't know, but not now yet lah. So you can go to my channel if you understand Mandarin even better, or you can go to the TDC official TDC Education YouTube channel to get the video for today's class. All right, guys. I tell you, during your next exam, before you go for your next exam in July, August, this is the video that I will recommend you to watch. Okay, Ken. All right. No problem, guys. Okay, so yeah. Today, thank you everybody for like finishing the whole thing, because today we're so greedy, we do like so many things, Okay. And thank you for staying until the end. So thank you very much. Okay, so good luck for exams if you have exams. So bye bye everybody. Bye bye. Bye bye. Bye bye. Bye bye. Welcome.